Hello everyone. So today's Leetcode question is climbing stairs. This is a easy category question. Question states that you are climbing a staircase. It takes n steps to reach the top. Okay. Each time you can either climb one or two steps. And how many distinct ways can you climb to the top? Okay. So basically, question is saying that we have to climb n steps, and we can at any stair we can choose that either we can climb one step or we can climb two steps. Okay, so we have to return how many distinct ways we can climb to the top. So let's understand it with the example. Okay, so let's say we have to climb 7 stairs. Okay, so initially we are on zeroth step. Okay, so here we can go first and we can go second stair, and here we can go second stair and we can go third stair. From here we can go third and fourth. Here third, fourth, fourth, fifth, fourth, fifth, fifth, sixth. After that, from three we can go four, five, five, six, five, six, six, seven, five, six, six, seven, six, seven, and 7, and we can go above 7. So here we do not take this place. Okay, from 4 we can go 5, 6, here 6, 7, here 6, 7, here 7, 6, 7, 7, 7. We are already on stair 7, so we can not go from here. Here we can go 6, 7. Here we can go 7, 7. We do not take this. 7, 7, 7, 7. Okay. So this is the way to reach 7. First we take 1, then take again 1, then take again 1, then take 2, then take 2. Okay. So in this recursion tree, there are many ways to reach 7. So how we can solve this? First we call our recursion for 0. Okay. And now if at any time, let's say 8 hour I, at any time we reach at 6, means I equal to n minus 1. Then we can say that we have only one way to reach n or 7. So in this case we return 1. Okay. And if we have on 7 I equal to n, then we can say that we cannot go from here. So we return 0 in this case. Okay. And in the case of n minus 2, let's say here 5. So we can go 7 and we can go 6, then 7. So we can return 2 in this. Okay, we have only two ways. So for 3, how many ways we can from here and how many ways we can go from here. These are the 3. So these 2 plus. Okay, so let's code this question. So I'm taking a recursion function. The argument in this is I and n. I start from 0. So what are our base conditions? If I equal to n, then return 0. If I equal to n minus 1, then return 1. And if I equal to n minus 2, you can simply return 2. Now we take one step. To take one, when we take one step, what we are doing, we increase our stair by 1. So I is stair here. So we can take this recursion I plus 1 comma n. Okay, and when we take two steps at once, then we can say that recursion of I plus 2 comma n. Okay, and add them. We return take 1 comma take 2, sorry, take 1 plus take 2. Okay, and return this recursion function. We return recursion and we start from 0 comma n. Let's run this code. The case are accepted. Let's submit. Okay, it shows it is shows it is showing the time limit exceed. So we have to reduce the time complexity. So here what we are what we are seeing that here for 2, here we calculate for 2 when we are on second stair, and again we are call for second stair and we solve whole. Okay, so if whenever we call for 2, we store them in a array at any index. Okay, 0, 1, 2, 3. Let's say this is a 4, 5. Let's make below this. Let's say here we have array of 7 length. 1, 2, 3, 4, 5, 6, 7. Okay, 0, 1, 2, 3, 4, 5, 6, 7. This is 8 length, but no, it does. Okay, so here we are on 5. We can say that from 5 n minus 2 it returns 2. So we return we store the value at index 5. Okay, so for 6 it is stored 1. Okay, now what is total base for 4? 2 plus 1, which is 3. So we store 3. So whenever it call for 3, it call for 4. it do not run all the tree. 4, 5, 6, 10, 6, 7. Okay. It see that I have already calculated for 4. So we can take this value direct. So it returns 3 here. It returns 3 here. Okay. For 3. Similarly for 3. What is the value of 3? For 4 it is 3 and 5 for 2. So 3 plus 2 equal to 5. So we store here 5 and it returns 5. So whenever call for 3, it returns 5. It returns 5. Okay. Whenever call for 3, it returns 5. Similarly for 2. Okay. So let's convert this question. Let's code this things also in our code. Let's reduce the complexity. So I take a integer array dp in new int of size n. Okay. And initially the element of this array is 0. Sorry, minus 1. And we pass this array in our recursion function, comma, int dp. Okay. So whenever if dp of I is not equal to minus 1, what it means? It means that we have already calculate the value of the ways to reach the top from this stair, ith stair. Okay. So we return simply dp of I, and here if it is not calculated, then here it is calculated and set the dp of I is equal to this value. Okay. Now let's pass dp in this also and here also. Okay. Now we can rule this test case when we are running. This is not statement to be equal. Now let's run this code. Our both our all cases are accepted. Now let's submit. Our code is submitted successfully. This is called memoization. Okay. Now you can also do tabulation in this code. So what is tabulation? Okay. So in the memoization, we start from top to bottom, 0 to 7. And now we in tabulation we have to start from bottom to top. Okay. So we run a loop 7 for array 7. So at 7, how many ways I can reach? 0. Okay. From 6, how many ways? 1. From 5, how many ways? 2. Now from 4, how many ways? 5 plus 6. 2 plus 1, which is equal to 3. On 3, how many ways? 4 plus 5. That means 3 plus 2, which is equal to 5. From 2, how many ways? 5 plus 3, 8. Add previous 2. And from for 1, 8 plus 5, 13. From 0, 13 plus. So it returns 21. Okay. So we can this things also. This is called tabulation. We do not have any, we do not require any recursion function. So we can uh, save our memory of function. Okay, so let's run the code. Int I from n minus 1 from n minus 1 to 0 and I minus minus where if I equal to n minus 1, dp of I is equal to dp of I is equal to 1, and if else if I equal to n minus 2, dp of I is equal to 2, and dp of I is equal to dp of I plus 1 plus dp of I plus 2. Okay, and we return dp of 0 because we have to start from 0. This is something like, okay, this if error okay. Now let's run this code. If declare 3 equals array dp. Now let's run this code. So our all cases are accepted now somewhere. So it's submitted successfully, and have we have do tabulation successfully. Now this dp array takes n o of n space. Okay, so do we can remove this space also. This is memory optimization. So what we are doing in this, first we take 1 and 2. Okay, we have 1 and 2. Let's say it's our first and it's our second. So add them, we got 3. Now our first pointer is moved here, second is here. Now add them, we got 5. Now first is here, second is here. 5 plus 3, 8. So 8. Now first is here, second is here. Now 8 plus 5, 13. Now first is here and second is here. Now 18, 21. Now first is here and second is here. How many times we have to run this loop? 1, 2, 3, 4, 5 times means n minus 2 times. Okay, so let's remove this array, PP array, and take int first. Initially our first is 1 and second is 2. Okay, and our code is running for n minus 2 times. I equal to 1, I less than equal to n minus 2, I plus plus. We took the answer and answer equal to 0 initially. So our answer is updated here, first plus second, and our first pointer is go to here, second. So our first is equal to second, and For second is go to answer. And we return here answer. Okay. Now let's run. It's showing 0. Okay, so we have to return here. Yes, because in the case when n equal to 2, our loop is not running and we return 0. So let's run now. Our all cases are accepted. Now let's submit this code. Test run wrong answer on 1. Okay, so we have to take one these cases where n equal to 1, then we return 1 because we have only one way to reach at 1 from 0. Now submit. Our code is successfully accepted, and here is the code after memory optimization. Thank you for watching.